The topic which we'll be dealing today is related to directory structure in file systems. Now we'll be covering the introduction to directory structure, the storage structure, what are the operations we can perform on a directory structure, and the various types of directory structures. Coming to the introduction, before we move on to the directory structure here, let me first give you a brief overview of what do you understand by the word disk or a drive. So these are nothing but your storage devices where you can store your data, and when you have your disk you can go for making up it into parts, so this you call it as a partition, and group of your partition or a chunk here will be called as a volume, and in each of these volume we actually go for storing our data. So when I say a data, that data can be stored in the form of a file, and group of the files clubbed together we can call it as a directory. And to maintain all these files onto a directory we need to use some particular system or a structure which we call it as a file system. So these are the general terminologies which you people need to be aware of while dealing with this directory structure. Coming to the directory structure here, as I told you, you have a set of files. And why do you want a file here? Because you want to store some data, right? So these files, when you club together, you store it in a directory. You can even call this as a folder, right? So this is a partition of a disk which is being made, and each of the partition has a directory, and each of the directory has some set of files. So each directory will maintain a metadata. Metadata, as you all know, it is nothing but a data about data. So what is your data here? A file. So you are maintaining the information about your file. So what are the different files present in that data directory, and what are the different set of attributes related to a file? We have seen the earlier class what are the attributes that are associated to a file, including the name of the file, type of the file, size of the file. So all these information related to a file will be stored in this metadata, and that has to be maintained in a directory related to collection of files. Now coming to the storage structure, we have different types of file systems which will designate how you store the data onto a file. So one is your temporary file systems. As the name implies, temporary file system, this will just hold the data which is volatile, and whenever you go for switching off your system, the contents of it will be erased. And you have another storage structure which is nothing but loopback. This particular file system will allow to be accessed in one place of the other. So loopback system allows one file system to be accessed in place of the other. And you even have one other file system which we call it as process file system, which maintains the data related to all the process present in a file. And you have a general purpose file system. So this file system will tell you how to actually store the file onto a directory. Now, having seen the file system, we'll now go on to seeing, moving on to operations on a directory. What all operations you can perform on a directory? What is actually present in a directory? A file, right? So you can search for a file whether it is present in a directory or not. You can create a new file in a directory, you can delete a file, and you can go for just displaying the contents of the directory. You can rename a file which is present in a directory, and you can just go through all the files which are present in a directory. And to perform all these operations on a directory or on individual file, we have a system called associated with each of the operations. Now coming to the next one, we have a directory structures. We have different types of directory structures here. We have single level directory structure, two level directory structure, tree level, and acyclic directory structure, and general graph directory structure. So this particular structure will tell you, structure as it implies will tell you how you can organize the files in a folder, how the files can be stored in a folder or it is a directory. Now we'll see each one of them in detail. Coming to the single level directory, as it implies, you have only a one directory, and all the files irrespective of the operation, all the files will be dumped onto the single directory. So you have only one directory specified at the root level, and you have to store all the files. And when you see this notation here, directory will be generally represented with a square symbol in the pictorial representation, and all of your files will be represented with a circle. So in well directory, you have a single folder pertaining to a user, and the user has to store all the files present in it. So .jpg, txt, all are stored under a single folder. So when you see this, what is the advantage? The implementation is very simple. And when the size of the file or the content present in the file is very less, searching will become easy. Creation, searching, and whatever operations you want to perform on a file, it is also very easy, right? But the disadvantage here is, since you have only single folder, you cannot have two files with the same name, and choosing unique name for each and every file will be a bit difficult. And when you want to search a file and the content of the files are very large, you have to go through the each and every line of it, so it becomes very difficult when the size of the file is very big. And here the protection is not provided because all the files are accessed to all the users. You are not designating a folder to a particular user. So to avoid that particular problems in single level, now we move on to the second directory structure, which is nothing but two-level directory structure. So what happens in two-level directory structure here is, for each of the user, we create a separate directory, and each user can maintain the files related to his purpose in that particular directory. So you have two things here, master directory as well as your user directory. So you can call it as master directory, and this is your user directory, UFD, or master level directory, user level directory. And each of these directories can in turn have the subdirectory. This is a file entry, and you have your actual files. So two levels will be maintained here. And the advantage here is, as it implies, you can, instead of searching, each user can just check the file corresponding to his folder and search in his own folder, right? And you can have two files with the same name in two different folders. And here your grouping is very easy because you are organizing according to the users, and the user cannot use one user cannot use the data of the other user without prior permission. And implementation is also same. But here the thing is, one user, without giving permission, one user cannot access the data of other user. So sharing is not at all possible here, and it does not allow the users to create subdirectories. So you will be given only the parent directory here. You are only need to go for creating the files in that. You cannot go for creating the subdirectories. Now coming to the next directory structure here, tree structure, you can even call it as a hierarchical structure or hierarchical directory, where at the root level, you have directories created for each of the user depending on the number of users accessing that particular system. And each user, you had a problem with the two level, right, where the user cannot go for creating subdirectories, whereas here the user can go for creating subdirectories. And here he can even maintain a file in that particular subdirectory, so you can go up to any of the levels. It is not restricted that it should be up to 3 levels or 4 levels. You can go up creating any level of hierarchies of creating a folders or your files. But when you see the internal implementation details, how do we now, by seeing visually, I can say that since it is represented with a rectangle, it is a directory, and if it is represented with a circle, it is a file. But when you go for the internal structure of the system, how the system will actually differentiate between a file and a directory? If a bit will be allocated for each of it, if a bit is 0 against that thing, you will call this as a file. And if the bit is represented as 1, you call that as a subdirectories. And when you want to go reach to a particular file, you have to start your path. For example, here my file name is text. Now, if I want to reach to this particular file, from where do I need to start? User to go to your folder F3, go to from user, go to F3, F3 to F2, and finally to this particular file. So when you actually mention it like this, user2 slash F3 slash F2, and then you specify the name of the file, this you will be calling it as a path. So path will tell you the hierarchy level from the starting of your root directory to the file actually what you want to either search, or whether you want to delete the content or you want to add the new content into it. So if your path, you're specifying a path name. If you're specifying your path name from the starting of the root directory to the last level where you want to access your file, that is your absolute file, absolute path name. Whereas you go for giving only one particular path name. If I just write slash f2 slash txt, I'm not specifying the root directory here. So this we call it as relative path. And as we all know, what all operations we can perform on a file here, we can go for creating a file. Similarly, you can go for creating a directory. As I told you, tree structure main advantage is it allows the user to go for creating a subdirectories. So you can create a directory, you can delete a directory. But when I say when I want to delete a directory, but we have to make sure that all the files present in that particular directory are to be deleted in order to delete this particular directory. And you can even search for a file which is present in the directory. And in order to perform all these functions, we go for using the system calls depending on the operating system. Coming to the advantage, as we have been emphasizing, it allows you to go for creating subdirectories. Since you are able to specify the path, searching is easy. And file sorting, you are able to create your subdirectory. So your organization is very important for you, right? So important data can be kept in one file, and data or the least frequently used data can be dumped into another folder. And here there is no limit on the number of levels, so it is more scalable. But here also you have a problem that one user cannot access the data of the other user. So you provide advantage in the sense is protection, but when you want a sharing kind of thing, that is not possible when I go for tree structure. And as you, there is no limit on the number of levels the subdirectories are to be created. The user can go on creating any number of levels, but it leads to complexity when as the number of levels increases. And users cannot modify the root directory data. He has to just use it as it is. Now coming to the next directory structure here, acyclic graph structure. Acyclic graph structure is in a sense here, what was the main disadvantage of your tree structure? Sharing was not possible. Whereas using this particular structure, sharing is possible. Now if I just see user 1 and user 2, I want a file to be shared by both the users. So F2 is a folder created by user 1 and F3 is a folder created by user 3, and both of them are trying to access the same file. This is a file. So this type of sharing is required when assume both of you are working on the same type of project and you want to store the data in a single file instead of multiple copies. So this type of sharing should be used. And if you want to go for this acyclic graph directory here, sharing can be done in two ways. One is you maintain two copies, right? But when I maintain two copies, whenever I make change to one copy, I need to even make a same changes onto the other copy. So every time I need to see that both of my files are consistent. So since it is not possible all the ways, we go for using a concept known as links. So when I go for links, we have two types of links. One is nothing but your hard link. The other you call it as soft link. When you go for hard link here, when you establish a link, so for accessing the shared data, when you go for your soft link, the main problem whether we are going for hard or soft links, the problem will come when I go for deleting a file. So when you go for your soft link, you only just delete the file. So when I delete the file, a link is being still existing, right? User one has deleted the file, but what is happening? The link is still getting attached to that. So this becomes your branch link pointers problem, where the data is not present, but the link is still existing. So that is a problem when you go for using soft link. Whereas when I go for using hard link, so in hard link, you try to maintain a counter. You first try to understand how many users are using it. Now, if I assume two users are using a file, right? So if one user has deleted the link, so in that case, you make your counter value to 1. And once the second user also doesn't want to use the file, he removes his link, right? So when the link value becomes 0 or the counter value becomes 0, the original file will be deleted. So the problem of deletion in your soft link, whatever you're getting, just by deleting a link or just by deleting a file, the link will be established as it is and the file is not there. So that problem can be overcome by using your hard link. A file will be deleted only when the two links are made absolute, means that I'm not using them at all. Coming to the advantage here, you can go for sharing of the file between the users, and you can reach to a file. It is not compulsory in order to reach to a particular file you have to use the same path. You can go for any of the path. And as I told you, deletion is bit complicated when I go for acyclic graph directory structure. The last directory structure is your general graph directory structure, where here you have a concept of cycles in this particular graph. In acyclic graph directory, as it implies, there were no cycles, but here when you establish the link between any of the directories or the subfiles, you get a cycle here. And this general graph directory structure is used for creating a directory within the other directory. And the deletion problem, whatever you got here, that you try to overcome in this general graph directories. And the complexity of this general graph directory structure is you get a problem in case of two things. One is while performing your search operation and while you are performing your deletion. So since you have a cycle, whether you are going for search or deletion operation, you may get a case where the link is again pointed back to your same. You started from here, the path you started from this path, and you are reaching the same path. So searching can be done twice, or when you are going for deletion, it is pointing to the same file once again. So to overcome this particular problem in your deletion, here we go for using a concept known as garbage collection, where you will be traversing your directory structure twice. First, to identify what are the files that are in use, and the second traversal, you go for identifying which of the files are not in use. And then you go for deleting this. But this garbage collection will take some amount of time. So in this session of operating system, we have seen the various structures of directories, how you actually maintain the data, and what are the advantages and disadvantages of each of the structures.